All right, ready. So, it says an airplane has a mass of 1.5 times 10 to the fourth kilograms, with 60 meters per second. Pilot then revs up the engine so that the forward thrust of the propeller becomes 7.5 times 10 to the fourth. If the force of air resistance has a magnitude of 4.0 times 10 to the fourth. Okay, so that means we have two forces going in opposite directions of each other. Okay, so if this guy right here, draw a fun little looking airplane. Okay, if there's our airplane, okay, it was already moving at 60 miles per hour. Or excuse me, 60 meters per second. So we have a forward thrust of this much, 7.5 times 10 to the fourth, and a backwards thrust of 4.0. Okay, so first thing, eventually, we are going to have to use the net force because those two things are kind of canceling each other out. All right, so now we want to know the final speed. We're speeding up, so it's a change in kinetic energy. So we use Work Energy Theorem. We can say that work is equal to a change in kinetic energy, which is KE final minus KE initial. Now, in this particular case, it's a little bit harder because it starts at a certain velocity and it's not coming to a stop. So neither of those terms cancel out. Okay, so KE final minus KE initial is equal to the amount of work that we have. Now, we also, we're going to look for a final velocity, which we can pull out of KE final. But we have to know what this is equal to. We don't know the amount of work, but we also have another way to find work, and that's W is equal to F times D. Okay. Now, that's actually going to be, since we have multiple forces, that's actually going to be a net force multiplied by our displacement. Okay, so we get KE final minus KE initial is equal to net force times D. Okay, so let's break that down a little bit. 1/2 mv final squared minus 1/2 mv initial squared. Yes, and that is again equal to net force times D. Now, do we have displacement? Displacement, that's here. All this is happening while we travel 500 meters. Net force is the combination of these two forces, 7.5 times 10 to the fourth and 4.0 times 10 to the fourth. Okay, so what is the combination of those? That would just be 3.5 times 10 to the fourth, right? Times 10 to the fourth. I combined this guy and this guy. They're going in opposite directions, so they're going to subtract. Okay, and then multiplied by our displacement of 500. Okay, then we can add in all this stuff. So 1/2 multiplied by 1.5 times 10 to the fourth times v final squared. That's what we're going to solve for. Minus 1/2. Run out of room here. 1.5 times 10 to the fourth. Just wrote e to the fourth to abbreviate, because that's the mass. Let me write this out a little bit neater here. $60. So we're going to square that. So now that we got all those numbers in there, we have all of our variables except for v final. So kind of have to multiply all that out and then get our final answer. All right, so now that once we put the numbers in there, this is what we come out with. Then we add this to both sides. So once we add that, we should get 7,500 times VF squared is equal to 4.45 times 10 to the 7th. Then 2 more steps. Divide both sides by 7,500 and take square root. So VF is equal to square root of 5,933. Giving us a final answer of 77 meters per second.